Today we're going to take a look at section 9.8. And I have good news about section 9.8. What's the good news? The good news is there's absolutely nothing new. Section 9.8 is kind of a compilation of things we've been doing recently. Nothing new in section 9.8. So here's what we have. It says, the percentage of law degrees earned by women are shown for various years in the table below. Let f of t be the percentage of degrees earned by women in the year that is t years since 2000. And basically what we're going to be doing in this section is we're going to have data, and from the data we're going to come up with equations. And we've been doing that all along. So the first one says, determine a quadratic equation for f of t using the vertex form of a parabola. All right, can anybody remind me what the vertex form of a parabola looks like? What's the equation where we look at the equation and immediately we know what the vertex is? That's correct. So we're going to have f of t is a times, I'm not going to use x, I'm going to use t because they told me to use t in this problem, t minus h squared plus k. That's a vertex form of the parabola. Why is it called vertex form? H and k gives me my vertex. Okay, so what I need to do now is I need to look at my data and see, is one of those points the vertex? And if so, which one, and how do you know? 2005, 48.7, you think is the vertex. I agree. Why do you think that one's the vertex?
It's in the middle, so it would have to be the maximum.
All right, well, it doesn't always have to be in the middle. You're right, this time it happens to be exactly in the middle. The second thing you said is more important. It's the maximum, isn't it? This is the biggest y value. What's a vertex? A vertex of a parabola is always the highest point, or it's the lowest point. In this case, our data is coming up, the values are getting bigger, and then they go down. That one has to be the vertex. When you have data, it won't always show up right in the middle of the data, but in this case it does. Okay, well, how does that help? How does that help me to find my equation? And what number am I going to plug in for h? 5, because we started in 2000. The data is since 2000. So h is a number 5 and k is a number 48.7. So f of t is a times t minus 5 squared plus 48.7. All right. Now, how do we find the a number? We pick a different point. We can't use the vertex. We already used that one. Pick any other point. Which one do you like? First one? Okay, so we're going to use this point, and we're going to plug it in, which means I'm going to plug in for 0. I'm going to plug in for t. What number am I going to plug in for t? Kind of gave it away as I was talking there. I'm going to plug in 0. And what number am I going to plug in for f of t? 45.9. And that will allow me to get the a all by itself. All right, so I'm going to have 45.9 equals a times 0 minus 5 squared plus 48.7. How do we get the a all by itself? Subtract 48.7. All right, 45.9 minus 48.7. I get negative 2.8 equals a times, well, what's 0 minus 5? And what's negative 5 squared? So I'm just going to write that as a times 25. And then how do I get the a all by itself? Divide by 25. So I get a is minus 0.112. And in this case, I probably would leave it as decimals since my data was given in decimals. I could have my calculator convert that into a fraction, but I'm dealing with decimals anyway. I'll leave it as a decimal. All right, so our answer is f of t is minus 0.112 times t minus 5 squared plus 48.7. There would be our equation in vertex form. Now, I think what I want to do, I think I want to type this data into my calculator and graph it, and then I think I want to graph this equation and see how well it matches, just to get an idea of how good it looks. Okay, so again, nothing new. How do I type this data into my calculator? Where do I go? Stat. Edit. Clear out the old stuff. Go up there, clear, enter. Clear, enter. 0, 2, 5, 7, 9. Go over to the other side. 45.9. 48.0. 48.7. 47.6. And 45.5. Okay. Quit out of that. How do I make my calculator draw that now? Before I do zoom stat, I have to do something else. I have to go, I got to turn it on, don't I? So I got to go to second stat plot and turn that graph on. And then I'm going to do one more thing. I'm going to go to y equals, clear out anything that's there, and I might as well type in this equation as long as I'm at it. So minus 0.112 times x minus 5 squared plus 48.7. Got that all typed in now. Now I agree with you. I would definitely not just hit graph because I have no idea what window it's going to give me. I would go zoom down to number 9 so that the window will fit my data. There it is. How well does that graph fit that data? You don't like it. Why not?
It only hits 2 of the points. It doesn't hit the majority of the points.
It hits exactly on the 2 points that we used. That's correct. This is the vertex. We used that one. This was the first point. We used that one. It's okay. I would agree it's not great. It's okay at best. But that's not surprising. I mean, we were given 5 points and we only used 2 of them. So it's going to be guaranteed to hit the 2 we used, but not guaranteed to be great on the others. So using the vertex method, probably not the best method to use for finding the equation. So we flip to page 2, and it says to try it a different way. Page 2 says, determine the quadratic equation for f of t using standard form of a parabola. Somebody remind me what standard form looks like. That's the ax squared plus bx plus c. Except I'm going to use f of t is at squared plus bt plus c. In the directions it told me to use t, so I'm going to use t. If you used x on a test, I wouldn't have a big problem with that. But again, if you're doing your homework on MyLab, if it tells you to use t and you use x's, it will mark it wrong even if you do all the work right. Okay, so this is what we did just the other day before taking our test. How did we use this equation to figure out a, b, and c? How many of them? We used 3 of them. We need to figure out 3 things, a, b, and c. So we went back here and we picked 3 points. It doesn't really matter which 3 points you pick. However, it's probably a good idea to spread them out. You probably don't just want to use the first 3 points. Why not? I mean, it's not a terrible idea, but not the greatest idea. Why not? What do you think is going to happen if you graph and you used exactly the first 3 points? It'll look really good on the left. It'll look really good with those 3 points. What about on the right-hand side? probably not so hot. So a good idea in general is to spread your points out. So if I were picking the 3 points, I would pick the first one, the middle one, and the last one. Spread them out a little bit. Okay? So I'm going to write those 3 points down. That's 0, 45.9 and 5, 48.7 and 9, 45.5. So those are the 3 points I would use. The directions didn't tell you had to do that. You could have just picked the first 3, but in general, better to spread your numbers out. What we did is we took those 3 points and we plugged them in. And that gave us a system of equations. So I'm going to plug them in. So I'm plugging in 0 for the t number. What happens when I plug 0 in for the t number? I get c. I get 0 plus 0 plus c would have to equal what? The 45.9. 45.9. Then I plug in 5. And again, I'm plugging 5 in for t. 5 squared is, so that's going to be 25a plus 5b, plugging in for the t number there, plus c is 48.7. And then finally I plug in 9. 9 squared is 81, so that one's going to be 81a plus 9b plus c is 45.5. All right, so we build our system of equations, 3 equations with 3 variables. How did we solve 3 equations with 3 variables? We really had 2 techniques. We used elimination. We didn't usually use substitution, or we plugged it into our calculator. And that's what I'm going to do. I certainly don't want to do elimination when I have to deal with decimals like this. Not that it's terrible. I mean, I got my calculator. I could use my calculator with those decimals, but I might as well just use my calculator altogether. All right, so how did that work? Where did I go to type these equations in? Into the matrix. Matrix is over here. Oops, you can't see where I'm pointing. Matrix is over here. So I'm going to go second matrix, over to edit, matrix A. And I need it to be 3 by 4. I got 3 equations, 3 down, 1, 2, 3, 4 things across, 1, 2, 3, 4. 3 by 4. I type my numbers in. Now what am I going to type in for numbers here? 0. There's no A, there's no B, so I'm going to use 0. So I'm going to have 0, 0, and then a 1 in front of the C, and then the 45.9. Second row, 25, 5, 1, 48.7. And the third row, 81, 9, 1, 45.5. Once I have all that typed in, I quit out of that, I go back to the home screen. Then how do I get the calculator to tell me the answers? Second matrix, over to math, down, down, down to B, which gives me row reduced echelon form, and then once again to matrix, and tell it to use matrix A. I think I'm going to round off to 2 decimal places. I think 2 would be enough. So what does this first row tell me? The first row tells me A is negative 0.15. Second row tells me B is 1.32. And then C is 45.9. But we already knew that, didn't we? We knew C was 45.9 right from the beginning. All right, so the equation we get this time is f of t is minus 0.15 t squared plus 1.32 t plus 45.9. Let's type this one in and graph it. What should happen, we know what should happen, it should be really good at those 3 points. So the question kind of is, how good is it with the other two? So I go to y equals, clear that old one out, minus 0.15x squared plus 1.32x plus 45.9. Draw me a picture, please. How's that one look? A lot better. It's always really pretty amazing to me how good an answer you actually get by only using 3 points. You really get a very good answer most of the time, and that's a good example. As long as you spread your data out. If I'd have used these first 3 points, like I say, it would have been real good here on the left. I'm not sure what it would have looked like on the right. Okay, so that one looks much, much better. All right, and then question C. Determine a quadratic equation for f of t using regression capabilities of your calculator. What does that mean? Nope. This is the easiest way to do it. You go to Stat, Calc. Which regression? By the second one, do you mean that one? Quad regression? No? Number 8? No, that's LIN. What does LIN stand for? Linear. Is our data a line? No, our data certainly isn't a line. I was on the right one, I think. I think we want, if you want, ooh, I went too far. If you want a parabola comes from what's called a quadratic equation. So if you want something with an x squared, you want quadratic, you want the quad regression. So really nothing new here. In the past we used number 4, we used linear regression. Today we want quadratic, so we're going to use quadratic regression. That's really the only difference. I need L1 and L2. We get f of t is minus 0.15 t squared plus 1.30 t plus 45.93. Rounding all of my answers to 2 decimal places. Let's type that one in and see how it looks. In theory, this one should be the best one. Minus 15x squared. Oops. Minus 0.15x squared plus 1.30x plus 45.93. Draw me a picture. Is that one better than the other one? Yeah, just a little bit, isn't it? The other one, it hit 3 points exactly. This one is not hitting that one exactly, but I think it's closer than the other one was. And the same with this point. It doesn't hit it exactly, but it's really, really close. So that, in theory, should be the best one. Questions on that? So question D was graph the equations, see how well they fit. We already did that. So where are we going with this? Why would I want to be able to? Why would I give you data and ask you to find equations for it? What do you think we're going to do? What do you do with an equation once you have it? Sometimes we solve it. What else do we do? We use it to predict more. And that's what section 9.9 is all about. So section 9.9, we'll have the data, we'll find the equation, and then we'll make predictions.